it's recording. There we go. Exercise 1G. You're looking at the length and midpoint of a line segment. Let's fill in some points. When you have 2 points that make a straight line from end to end, we call that a segment. You can use Pythagoras' theorem to find the distance of a line segment. So here's pictorially, just so you can picture it. If you had a Cartesian plane, that's called a Cartesian plane, XY axes. I picked 2 random points. Point here, so X1, Y1. You get that point. And then you get another point, let's say down here. And I'll call that X2, Y2. So this is X2, Y2. Then the point-to-point line, so if I connected the 2 points together, it's got a line segment. When you're saying distance, you're just saying, well, how far is it from that point to this point? When it's vertical and horizontal, it's easy to count. When it's in a diagonal, then it changes the problem. So for example, if I said this is 1 and that's 2, and then this one is 1 here, and I made 2 points here, and I said, what's the distance between 1, 1 and 2, 1? Well, logically, you can look at it and say, well, it's a distance of 1. So when it's horizontal or vertical, it's easy to count. When it's diagonal, that's where we then have to use some sort of theory. Now, if you look at it in terms of its like the diagonal shape, anytime you have a diagonal shape, there is a vertical length and a horizontal length. This is where the theory comes from. So, to find the distance formula, which I already put in for you, the distance formula is here. That's your distance formula. X2 minus X1, what does that mean? It just means find the horizontal distance. X2 minus X1, how far are these 2 points? How far is that? Square it, which I'll tell you why we square it later, plus y2 minus y1 really just means find the distance vertically, and then you square it. Now, where does this come from? It's Pythagoras' theorem. See, if you think about it, that diagonal line that I just drew, 1 point to the next point, did you see what you're doing? This is a right angled triangle, and when we say x2 minus x1, you're really calculating this length. That's what x2, and then the distance from x1 to x2, that's what x2 minus x1 does. It tells you the distance. Then when you do y2 minus y1, you're really just calculating the vertical distance. That's why you do y2, take away distance of y1. But then if you've got that, what's Pythagoras' theorem again? Anyone remember? Hands up. You know. Good. And C is the key one. C is your hypotenuse. So this is your hypotenuse, which is the length you're trying to calculate. That's called the distance. Yeah, from this point to this point, that's the distance. So to find C, Una said before, it was C squared is equal to A squared plus B squared. So if this tells you the distance of A, x2 minus x1, well, that's why we do x2 minus x1 squared. That's where the formula is coming from. Plus, where's B squared? Well, B squared is this length, the vertical length. That's why it's y2 minus y1. That's why it's y2 minus y1 squared, because it's A squared plus B squared. Where's the square root coming from then? Anyone see why we have to have this square root? Yeah, your job is to find C. C is the length horizontally, diagonally. So I don't need the square. To get rid of the square, what you would have done is you would have said square root both sides. That cancels out, and C equals to the root A squared plus B squared. And that is a summarized version of what we're writing here. So as long as you have 2 points, square root of A squared plus B squared, that's how you find the distance. The reason why I explain it that way is that you don't have to memorize that rule. I do teach it pretty much year 10, year 11. I have to remind them. Some of them will write it in their formula sheet. But by the end of year, I don't think in year 12 that you'll have that formula. It's assumed knowledge that you should know. At year 11, I think you can still have that formula. But by the end of it, you'll pretty much know it logically. Okay? So that's where it comes from if you didn't know how to use it. Let's do an example just to consolidate your understanding. Let's say I got the point 1, 1 and 3, 3. So here we go. I'll draw it in. 1, 1. So this is my point. And then I pick another one. I say 3, 3. Let's just say it's here. So that's my 3, 3. And this is 1, 1. And we're trying to find the distance between 1, 1 and 3, 3. You can look at it logically at this moment. Horizontally, how far is that? Someone said it. I just didn't see who. Is it Samuel? 2. And how would Samuel have gotten 2? Well, logically, 3 to 1 or 1 to 3, that's 2 units. But mathematically, what you would have done is you would have said 3 take away 1, which really is x2 minus x1. That's what you're doing. You're actually saying take the final coordinate of x, take away the initial coordinate of x. That's why it's in the formula. You would have done x2 minus x1, and then we're going to square that later. Plus, now let's work out y2 and y1. So how far vertically is this now? In the diagram. 2 again. So again, we know this has to also be 2 units. Again, from 1 on the y values, 1 to 3, that's 2 units. But how do you know? Again, you're really just doing y2 minus y1. So that's what I'm writing here. That's y2. It's y1. Doesn't matter which one you pick as y2, y1 because it's a ratio. And hence, the answer or the distance is always going to be the same. So here, y2 minus y1 squared. That should tell you distance. Let's put it all together. It's square root of, you already said that was 3 take away 1 squared plus 3 take away 1 squared again. That works out to be square root of 2 squared plus 2 squared. 2 squared is 4. 4 plus 4 is 8, so root of 8. So my distance, actually I've got a lot of space down here. Maybe I'll just write that over here. The distance is square root of 8. Anyone know how to simplify this? Otherwise we'll do that in the next, I think, chapter when we get to indices. Anyone know how to simplify root 8? Hands up. Raph?
Is it like 2 root 4 or something? 2 root 2?
2 root 2 is correct. For those who aren't sure yet, it's okay. We're going to be learning an exercise on how to simplify surds. The idea is to figure out all your squared numbers. So you know 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So you just need to know your squared numbers. And the question is, can you break the 8 so that it has one of these squared numbers? Now 8 can be broken up into 4 times 2. And 4 is a squared number. Why do we do that? Because we know that you can split it up to root 4 times root 2. That's one of the rules that you'll eventually figure out. That root 4 times root 2 will give you root 8, but since you can split it up, root of 4 is 2 like Raph said, and 2 times root 2, we're too lazy to write that time symbol, which is why we write it as 2 root 2. Okay, so later on you'll figure out ways. So as long as you know your squared numbers, you can then simplify surds. If you don't know it, it's okay. Type it in your calculator and it should reduce it for you, especially with a CAS calculator. It'll do that for you. So far, so good? That's one of the formulas. Okay, so most students, by the time they get year 10, year 11, this is called coordinate geometry. It's one of the basic formulas that you should know. Okay? Your second one is called a midpoint formula. So here with the 2 points again, x1, y1, x2, y2, the formula is x1 plus x2, then divided by 2. And then y1 plus y2 divided by 2. What is a midpoint? Well, midpoint just means that where's the middle? If I had to find the middle of this line, between these two, this segment, where's the middle? And if you think about it on a logical sense, this is where you start to understand why the formula is as it is. Why is it x1 plus x2 divided by 2? Does anyone know why that's the case? What's the reasoning? So if I had this graph over here, and I wanted to know the middle, which is here, that's the midpoint. Y is the formula x1 plus x2, so this point plus this point, and then divided by 2. And then y is the midpoint of the y coordinates, this point plus this point, which is the vertical part, and then divided by 2. Anyone know? No clue? No one? He is, but clarify that bit.
Like if you were to do x1 plus x2, that's 1 plus 3, which is 4. And you divide that by 2, you get 2.
Which formula do you know that you might have learnt from year 7, 8 or in primary school that you add the numbers and then you divide, in this case 2 sounds a bit confusing, but you're essentially adding and then dividing. Average. Do we know what the average does? We say it's sum of numbers divided by numbers, number of numbers. That's the algorithm. But what are we doing in the average?
Finding the in the middle.
Yeah, that's why people get confused between median and mean. Mean gives you the overall answer if everyone were to get the same answer, right? So for example, in this test, in this class, let's say logically we know that some students will get 100%, some students could get 80%, some students could get 65%, right? An average basically means if I walked into the class and I took your number and I took your number, so 90%, 60%, I add it all together, I get a total, right? And why do I divide by number of numbers? Is because I'm essentially saying if everyone here was to get the same score in this test, now I would have closed my eyes and picked someone, what would everyone get? That's what the average means. That's why when I say if I've got a class that has an average of 90%, it's crazy. Because what that implies is if I walk into a class and I just randomly pick someone and everyone had to have the same score, in this particular class, that would be 90. That's why an average of 90 is crazy. Whereas if I said an average of 30, that means if I summed all of your scores together and everyone was to get the same score, well then it doesn't matter who I pick, someone is going to get 30 on average. Does that make sense? So it's on a long-term concept that on average, no matter who I pick, that's what I should expect. Okay? There is a flaw between an average and a median. Anyone know? Why do you think at year 12 VCE, they don't quote the average, but they quote the median? Some schools will quote the average because they're skewing the data there. Why? Or what's the problem with the mean versus median?
The mean can be influenced by extremes.
Good. That's right. And because we said just then, notice here, x1 plus x2, this is what Nishi was saying, it was 1 plus 3. What it does is it gives you a total. And when we want the middle, of course we halve it, right? So we got the total, and then I halve it, of course I find the center, where it is. So now, in case we're trying to find the midpoint, that's why we divide it by 2. But what's the problem with the average is the total. I can have students who get 80, 81, 80, 81, and then one kid who gets 150. And I'm doing bonus questions. That will change my average overall. Because then we can see that we should expect that my average is about 80. If you found the median, it's clearly going to be in the 80s. But you type this in now. Let's try it. I'm going to do it on a calculator. Let's go calculator. Let's have a look at what this will give me. 80 plus 81 plus 80 plus 81 plus 150. How many numbers is that? That's 5. 1, 2, 3, 4, 5 divided by 5. Woo! Look at that. 94.4. But if you looked at my class data, no way am I actually getting an average if I close my eyes and I picked anyone. It's not true I'm going to get 94.4. That 150 is what changes it. That's why when it comes to VCE data, you'll see that they'll quote each school. They'll talk about the median and not the average. If they talk about an average, you'll probably have to then question why, because there's a reason why they do the average. It makes it look better. So imagine I said, my class average is 94.4. You'd be like, yeah, this guy's pretty good. I mean, 80 is not bad. I'm just saying it skews the data. Okay, and that's what people do. There's knowing the difference between median and mean, why that happens. And Samuel, you're correct. It is heavily influenced by extremes. So answering your question here, or if you're wondering, why is the formula the way it is? What we're really doing is you're calculating the total horizontal distance. And if you want a middle, you share it equally. That's why we divide it by 2. And the same thing, vertical distance, add it all together, and then halve it. That's how we get the middle. And so you get the middle of the y, middle of the x, or wherever that point is, that's your midpoint. That's logic. Okay, a lot of students will misinterpret this and they'll think it's x2 minus x1 divided by 2. That's the common mistake, because they're memorizing it and not really thinking what is the midpoint. But if you didn't understand any of my theory just now, if what I just described was way off and you're finding it too theoretical, memorize those 2 points, or 2 formulas. Okay, those two you'll need for year 9, 10, 11, and then by the time you get to year 12, it's not on the formula sheet, I believe. It's just you need to know that. It's almost like your times tables. You don't have times tables for your exams. You just need to know it. Here we go. Let's do some examples then. Let's do these two examples now. So if we're able to do this, find the length between the two coordinates. Let's test your understanding. What is the formula for the distance? Can I please have, let's go with Sean. What's the distance formula again?
X1, X2 minus X1 plus X and Y2 minus
Good. We're missing something. Squared. Very good. Make sure to have the square. Pythagoras' theorem. And it doesn't matter which one's x1, y1. Okay? You just pick. So here, we call it x1, y1, x2, y2. You could have done it the other way around. The answer is going to be the same. So here we go. Let's do it. X2, x1. So 3 minus a negative 2 squared plus y2, which is negative 1 minus 7 squared. Square root. Notice the whole time my layout, it's all vertical. I use brackets very consistently. Negative 2, so that's 5. So that's 5 squared plus negative 8 squared. That gives me now 25 plus 64. And 25 plus 64 is 89. Can we simplify 89? Anyone can think of two factors? Oh, that's true. But we need it to be times only. But good idea though. So yes, you can do 81 plus 8. The problem is you can't, there's not a rule that says you can do that, unfortunately. And when we get to certs, I'll explain why you can't do that. But you can do it for times. Okay? Good try. It was very good. Otherwise, I don't think there's anything else. You just need to think of two numbers that multiply to give you 89. So factors of 89, one of which that you can break down. Oh, this bit. Yeah. So the negative 8 times negative 8 becomes positive. Yeah. Oh, that's another point to note as well. Does anyone know the restriction of a square root function? What can't you do? What can't you square root?
0.
No, square root of 0 is still 0. You can do root of 0. So I can do it on my calculator. Where's root of 0? I don't even know how to use this one. I should use the senior one. But yes, root of 0 is 0. What can't you square root of? Negative numbers. Try it on your calculator if you like. And the logic here is, can you think of, because remember, square root is the inverse of squaring, right? Can you think of a number that you can square that will give you negative 1? Or can you think of a number that you can square that gives you negative 4? And you'll find that you can't. At this moment, until you get to SPECH, we do complex numbers, then that's solving a problem, yeah? So, why am I mentioning the limitations of the square root? It's because you'll always get an answer. It's a distance formula. Imagine you had a distance that was negative. Wouldn't work. So, the square root has a condition that the numbers always have to be positive. What's one of the things that we notice? Every time you square a number, what's the number going to be? Positive. And then you're adding on another positive. Every time you take a positive plus another positive, the answer is always going to be positive. If it's possible to take away, it also means that there's possibility of it being a negative answer, which won't occur. Okay? So that's why the distance formula will always work in the sense that it will always be a number as long as you've got 2 points. All right? Let's do the midpoint. What was the midpoint formula? Again, can I please have, let's go with Sahaj.
X1 plus X2 equal 2, and then Y1 plus Y2 equal 2.
Beautiful. So again, doesn't matter which one's x1, y1, just pick. I always just like to follow it in order. So x1, y1, x2, y2. You pick and choose. Doesn't matter which one. So in this case, my layout, it should be x2, let's call it 3, plus a negative 2 divided by 2. And then the other one is y2, which is negative 2, plus negative 6 divided by 2. Your answer should be 3 plus a negative 2 becomes 1 on 2. And negative 2 plus a negative 6 becomes negative 8 on 2. Simplify your fractions where possible. Don't change them to decimals. Okay, get into a habit. Don't try to use decimals. As you carry on with methods, we will stick with fractions and exact values. Okay? So far, so good. These are the fluency parts of the questions that you're going to be working with. So fluency skills, questions 2 to 5 or 6, that's pretty much what you do. 2 formulas and you apply 2 points. On the back page, we're going to do some word problems and problem solving. Okay, so let's see if you can apply the formula and now do a bit of problem solving. What if we work backwards? Okay, so I'm going to go to the next page. If you're ready. Have a look at the next one, and I want you to think for a moment before you copy my solutions here. This is problem solving. Now I'm getting you to think. You got the 2 formulas I gave to you. They're giving you 2 points, 1a and 3,7. They tell you that the distance between those 2 points is root 13. What do they want? What must a be to make sure that you have a distance of root 13? Anyone have an idea of the first step? Have a think. What are we going to do? That's very good. So usually in the sentence, look for key words. So later on when you're doing other subjects or topics, the key words tell you where to start. So when they say distance between these 2 points, you should be writing down d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Let's fill in the points. I already know the distance. They told me it's root 13 is equal to the square root of x2, which doesn't matter which one you pick, but I like to stick to just the chronological order. So I'll just do that. So that means my x2 would be 3. So I have now 3 take away 1. That works out well. Plus, well now y2, this is where you have to be comfortable with having a parameter. So it'll be y2, which is 7, take away a, which is y1, and then you square. Let's simplify it, and then you tell me what to do next, okay? So here I've got root 13 is equal to the root of 3 take away 1 is 2, 2 squared is 4, plus, now I'm up to 7 minus a squared. What do we do now? You can do logic. I can teach you a bit of logic here too, but just think, I want to see what you're going to do. Raf again. Subtract the 4 from both sides. There, you can, but mathematically there is one thing you have to do first before you can do that. Good, you got to get rid of the square root, because if you subtract 4 on both sides, what you're going to get is this. Because the surds and the numbers, they're different. Okay, you're working in a surd system, then surds with surds, numbers with numbers. In this case, 4 cannot be subtracted from the surd because we don't know what that is yet. That's why it doesn't fit in. But if you do what Roanne said, get rid of the square root, then it's just numbers, no more surds. How do you get rid of a square root? The opposite of that, which is? Square. So here I can say square the left-hand side and square the right-hand side. Now we know that if you square a square root, you're undoing the problem. It's like saying root of 9. What's root of 9? 3, and then I do squared. What is that? 9. So it's almost like saying cancel out the surd and the squares because they're inverse operations. So if I do that, it cancels out the square roots. What are you left with? You are now left with 13 is equal to 4 plus 7 minus a squared. And now what Raf said is correct. You can do this. See, these are numbers. There's normal surds, so I can collect numbers with numbers. So yes, you're right. You can do subtract 4 on both sides. 4 take away 4. Yes, that cancels out. 13 take away 4 gives you 9. And then we're still up to this point now. Now you can use a bit of logic. 7 take away something, and if you square it, it equals 9. You'll probably figure it out from there. What's the number? 4. Because we know the square of what number gives you 9? Has to be 3. and therefore 7 take away 4 will give you the 3. Now that's through logic. How do you do it algebraically? This is how you do it. BODMAS. Right now, you got to get rid of the square first. Yeah, BODMAS, you're going backwards. So Sam Dobb, got to get rid of the indices first before you do the subtraction there. To get rid of square, what's the opposite of squaring? Square root. Now, there's something I haven't taught you guys yet, but I'm wondering if you learned last year. Have you guys learned quadratics last year? All right, yes and no. Well, then note this for yourself. Every time you square root a number, can you please write down that the answer can be plus or minus? Okay, that'll be very useful as we go forward. And the reason why is 7 minus a, I may not know what that is, but I do know the square of a number has to give you 9. Now, negative 3 squared still gives you 9, and then positive 3 squared also gives you 9. So this is technically quadratics at this point, but I know you guys haven't learnt it yet, so the back of the answers will keep it as positive. But just for your reference, every time you square root, you should put in a plus or minus answer. So technically, there are 2 answers that this can be for A. You were correct before in saying it's 4, but if you solve this bit now, for those who don't know what I'm doing there, plus or minus just means that the number could be 3 or could be negative 3. So 7 take away A, so what I'm saying is you've got 2 scenarios. Scenario 1, 7 minus something has to equal to positive 3. Or scenario 2, 7 minus something has to equal to negative 3. Back to year 7 maths. Trying to solve for A. Let's go. How do I solve for A here? There's a lot of ways to do this. I personally don't like the negative A's. Remember how I told you I don't like negatives in the fractions? What I would have done here already is I would have times everything by negative 1. And I do that because this becomes a positive A, this becomes a negative 3, and then it's easier to solve from here for me to say plus 7, because that's a minus 7. Negative 7 plus 7 cancels out, and that tells me A is equal to negative 3 plus 7, which gives you 4, which is what you guys said before. Great. That worked if it was a positive 3. But there was another hidden answer, which once you get to quadratics, you'll understand why we have 2. Here, if I did the same thing again, times them all by negative 1, just because I like working with positive numbers. So here you get negative 7 plus A is equal to positive 3. And then we do the same. Add 7 on both sides. That cancels out. A is equal to 10. Let's see if that makes sense. 7 minus A, what does that give you? 7 minus 10. What does that give you? 3. Not just 3. Negative 3. And then negative 3 squared? 9. So that statement is still true if I had A. So that means in your 2 points there, you could have the point 1, 4 and 1, 10. So if you think about it on a graphical sense, 1, 4 or 1, 10, these 2 points, and the other point was 3, 7. It must mean that you could have 2 possible lines that connects to 3, 7. So you could have 1 and A could have been 4. Yep. And then A could have been 10. And that way you've got 2 potential points to make a straight line. But to make your life easier, I'm pretty sure your textbook won't go to that point because you haven't learned quadratics. It likely would have just kept it to this part here. They would have kept it as positive 3. Okay, but the logic is by the time you learn quadratics, there's a potential answer on the other side as well. Okay, there's many ways to get one answer. All right, so I can understand if you got confused at this step. Don't worry too much. I just wanted you to know that there's 2 possible answers there, plus and minus. And I'll stop there. That's it for today's lesson. That last one is a problem-solving one. I believe it was part of your textbook, I think it is. Check your textbook, see if the answers are 2 answers or whether it's just 1. But that's how I did it. Okay, I'm going to stop the video.